this, a lot of this chapter is review, but not all of it is review. So we're going to learn something new today, which is called Gaussian Elimination. Do you guys remember Gauss? Yeah, we've talked about Gauss before. He's a very famous mathematician. He did a lot with sequences and series. But for today, he did some things with matrices and kind of organizing data. All right, so these first couple examples start out super simple. We're not going to use a matrix to solve them. These systems are in what we would call a triangular form, and you guys can kind of see the little triangle here, right? So we have z is equal to something, and then y and z make something, and then x, y, and z make something else, right? So that's when it's in triangular form, and it's always nice when things are in triangular form. Okay, so if they're in triangular form, it's super simple to solve, okay, because we already know what z is. Z is equal to 2. All right, so if I'm trying to find y, then I just go back into y plus 2z, and I say, oh, well, z is 2, and plug it in. So I get y plus 4 equals 7, so y is equal to 3. So now we have y. And of course, once we have z and we have y, then we go back to that top equation, x minus 2y, so 2 times 3, plus 4 times 2 equals 3. And we solve. Okay, back table, you guys need to pay attention, take notes. I see you guys working on your homework. All right, so I'm going to have x minus 6 plus 8 equals 3, like that. So I have x plus 2 equals 3, so x equals 1. Okay? So this is what we call back substitution. It's starting with z equals, finding y equals, finding x equals. And it's really easy because it was already in triangular form. Okay, so the next one, same idea. We have 2z equals 6, so right away we can get z is equal to 3. And we work backwards. So we say, okay, well, y and z, we have an equation with y and z. So negative y plus 3z, which was 3, is equal to 9. So negative y plus 9 equals 9. So y is equal to 0. And then I go back to the very top equation, x plus 2y plus z equals 7. So I have x plus 2 times 0 plus 3 equals 7. So x plus 3 equals 7. So x equals 4. And then we have our answers. Does that make sense? And then you can write them as points. Remember, you can write it as like, the first one would be 1, 3, 2. And this one would be 4, 0, 3. Right, they're points in 3 dimension. Just makes it easy for me to grade too when you do that. All right, so most systems of equations aren't like this, right? These ones are super simple because they're in this triangular form. Okay, and I gave you a couple examples where you had to do that on like the very first homework assignment, right? And it takes a while. If you have a system of 3 equations, it takes a long time to find it. Okay, so Gauss invented something that's kind of a shortcut. So it's called Gaussian Elimination. And it's to change the system into what we call an equivalent system. So this is a method that can be done by hand, and it's often a requirement in college classes. So if you guys are going to take some kind of freshman level math class, like finite or whatever, I know that they definitely do this in finite at IU. And I tutored a lot of people on this, so it's very important. All right, so operations that yield an equivalent system. So it's just like if you have equations. What are we allowed to do with two separate equations? Well, we can add the 2 equations together to get a new equation. Right, we've done that with elimination. You can multiply one of the equations by a number. Do you guys remember when we did that? Like if I had 2x plus 3y equals 5, and I had 4x minus 2y equals 7. Like we could multiply this one by a negative 2, and that was totally allowed, right? So we can multiply by a scalar. Or we can switch the order of the rows, so we can move things around. Okay, so these are the operations that we will be doing. Okay, so it says I always follow these steps for Gaussian elimination. So I interchange the rows to get it as close to triangular form as possible. If possible, I get a 1 in the upper left-hand corner. I circle the term, and I use it to eliminate the numbers below it. So I'm in other words, I'm making them 0 by, I'll just say by elimination. And this will make more sense in a second. All right, so then I try to, I divide to get the number in row 2, column 2 equal to 1. So then I circle this term. So it's the second variable in the second equation, right, row 2, column 2. And I eliminate this variable in the equations below it. So again, I use addition, like this elimination method, to get rid of the variables below it. And that will make more sense in a second. Okay, so we repeat the process until we have the identity matrix. Okay, so really it just takes some examples. So we're going to do an example and make sure you're paying close attention to this, because I only do 2 examples because they're kind of long. I can do more if you want, but we'll see if you guys kind of understand this after the first 2 examples. Okay, so the first thing I'm going to do is I'm going to write the, what do you call it, the coefficient matrix. So I'm going to have 1, 3, -2. But I'm going to adjoin those other numbers too. So I'm going to do like a little dotted line, or you can do it just a straight line. It doesn't matter. And I'm going to put 0 on that side. Then I'm going to do 2, -4, 1, and I'm going to put the 10 over there. Then I'm going to do 1, 2, -1, and I'm going to put a 1. Okay. So it's the coefficient matrix, but I've adjoined the constant matrix. Like I've attached it on the end. Okay. My first step is always to get this as a 1 if possible. So I made it nice for you. It's already a 1. We're good. Okay. So once you have that as a 1, we want to make these zeros. Okay, so it seems kind of weird to do that. Okay, I always want you guys to think about the equations that we have. Okay, so I'm going to write this out. Don't write this portion out, but everybody look up here. This is what we have right now. We have x plus 3y minus 2z equals 0, and we have 2x minus 4y plus 1z equals 10. If I want to eliminate this 2x and make it a 0, I want it to go away completely. Do you guys see how I could multiply the top one by -2 and then add straight down? Do you guys understand that? Okay, what Gauss did is he's doing all of these steps, but he's not writing all the x's, y's, and z's and so on, and he's kind of doing a little bit of it in his head. So do we think we can handle this? So when he does that, right, see the x's go away, you end up getting 0 minus 10y plus 5z equals 10. Do you guys see that? Okay. So what we do is we're going to write that on the side of this matrix. I should have left myself some room. I'll just go ahead and rewrite the matrix. And you might have to take out extra paper for some of these. They do get long. Okay, so what I'm going to do is I'm going to take, I just told you, like, what we're doing is we're multiplying the first row by -2, and we're adding it to the second row. Does that make sense? So we're going to do -2 times row 1 plus row 2. So I'm writing that on the side there. I'm telling myself what I'm doing. And when you get really good at these, especially when you do these a lot in college, you'll do these for like 3 weeks in college. It takes for a long time. We're going to, you'll be able to do a lot of it in your head. Okay, so you're not going to have to write that side note that I wrote over here. You're going to like understand how to do that, okay? So think to yourself, if I'm doing -2 times row 1, so if I do -2 times this right here, what do I get? -2. When I add that to the row 2 item, what do I get? 0. Do you guys see how it works? So I'm going to leave myself a little note, but I'm going to get a 0. And the top row is going to stay the same. So I'm going to have 1, 3, -2, 0. All right, now I'm going to do it again. So now I'm going to take -2 times 3. What do I get? -6. When I add it to the second row, -10. Do you guys see it? So then we have a -10 there. All right, same idea on the next one. So I'm going to do -2 times -2. 4. I add it to 1. I get 5, right? And then the last one, if I do -2 times row 1, -2 times 0 is 0. Add it to row 2, 10. Okay, do you see where that equation came from? It's this. we're doing exactly the same thing, we're just shorthanding it. We're not writing all of the x's, y's, and z's. Do you guys understand that process? All right, now we're going to do the same thing for the bottom row. Okay, so let's think about the bottom row. So think about these, well, not those two equations. Think about this equation and this equation. And you can write them out. If you guys need to off to the side, I will not judge you if you have a bunch of like handwriting on the side. Especially the first few times you do this, sometimes it helps. What do we need to do in order to combine those and get this right here to be a 0? I need to multiply what by -1? Either one, really. But what we always do is we use that top row and we multiply by something. Okay, so I'm going to take the top row, I'm going to multiply by -1, and then I'm going to add it to row 3. So I write myself a little note. So I say, okay, I'm going to take the top row. Let me get rid of all these marks that I did. I'm going to multiply by -1. So -1, row 1, added to row 3. So I'm writing myself a little note so I remember what I did. All right, so I'm good. So -1 times row 1 is going to be -1. All right, I'm still right here. And then I add it to row 3, and I get 0. That's exactly what I wanted, right? That's why I'm doing this. All right, the next one. -1 times row 1 is going to give me -3. I add it to 2. -3 plus 2, -1. Okay, the next one. Can you guys kind of do it without me circling? -1 times -2 is 2, correct. And then plus that -1 gives you 1, exactly. Do you guys see what I'm talking about? So we did -2 times -1 gave me 2. I added it to this and got 1. So some of you guys will be really good at doing these in your head. Some of you guys are going to have to write it out to the side. It's fine. I understand. All right, the next one. -1 times 0 gives me 0. Added to 1 gives you 1. Okay? So that's always the process we do. We get a 1 here, and then we get 0s here. Okay, now our next step, we're going to get a 1 here, and then we're going to get 0s here and here. Okay? Can we do it? All right, so if I want a 1 there, you can do a couple different things. Like you could, whoops, lost my 1. You could like divide by -10 on that row too. Do you guys see this? Like if you have the equation -10y plus 5z equals 10, couldn't you just divide both sides by -10 and get a 1y? You could do that, but I'm going to avoid that. Why might I avoid that? Why is that a little bit messy? You're dividing it and you're getting what in result? Like you'll get a fraction. Do you guys see how you have a fraction? So we don't want to do that if we don't want fractions, okay? So what we can also do, remember there's these different rules up here, is we could switch the order of the rows. And this is where it might be convenient to switch the order of the rows. Okay, so do you guys see that row 3? It's almost a 1, right? I'm going to switch these 2 rows. So I'll go ahead and do that step. So I'm going to keep the top as 1, 3, -2, 0. And then I'm going to have 0, -1, 1, 1, 0, -10, 5, and 10. Okay, but I want this to be a 1, not a -1. So that's when you're going to multiply it all the way through by 1, or by -1. I didn't leave myself much room, so I'm just going to write it here. So I'm going to multiply by -1. So when I do that, I'm going to have 1, 3, -2. And some of you guys can do these steps, like you can do multiple steps all at once. But if you need to write it out, it's fine. Okay, so we have a 1. That's what we wanted. Good. So now I want this to be a 0, and I want this to be a 0. So get a 0 there. Get a 0 here. Okay? So again, if you need to write it off to the side and think about what equations you have, you can always do that. So I'm going to write this. I wouldn't write it if I was you, but you can if you want. Here's what I have. I don't have any x's now, but I do have a y. I have 1y minus z equals -1. Okay, and I want to get rid of this y here. I want it to be a 0. So what would I multiply equation 2 by? -3. So when I add it straight down, those y's will go away. This will end up not changing our x's at all, but it's going to get rid of that y. Did you guys see it? So once you have a 1 in that spot, then we say, okay, well, I'm going to take that row 2, and I'm going to multiply it by -3, and I'm going to add it to row 1 to be my new row 1. Okay, but that second row right now is going to be the same. It's the one that we're working with, so it's the same one. Okay, can you do it? Try it. So do -3 times row 1 or row 2, add it to row 1. So -3 times 0 is 0, added to row 1 gives you 1. See how it doesn't change that 1 that we've already gotten? All right, -3 times row 2 is going to be -3 times 1, so -3, plus 3 gives you the 0 that we wanted. -3 times row 2 gives you 3, plus row 2 gives you 1. -3 times -1 gives you 3, plus 0 gives you 3. Okay. Did you guys see that?
My question.
Yes.
Why are we doing this method? It's so long.
It's fast once you actually learn it. So I'm taking a long time, though, to explain it, aren't I? All right, so next one. So if I want to get a 0 right here, and I want to keep that 0 that I had before, how do I get rid of this? What am I going to do to row 2 to get rid of that? Yeah, multiply by 10, right? So I'm going to do 10 times row 2, or yeah, 10 times row 2 plus row 3. And that's going to be my new row 3. Okay? So when I do that, I get a 0 and a 0 like I wanted. You can check it if you want, because you're going to have 0 plus 0, and then you're going to have 10 plus -10 gives you 0. What about this next spot? What's it going to be? Yeah, so you're going to have 10 times -1 gives you -10, added to 5 gives you -5. And the last one, so if I take this times 10, I get -10, add it to there, so I get 0. Yep. All right, and then we do one last step. So what do you think we're going to do now?
1 on -5.
Yep, exactly. See, Tyler Watt, you got this figured out. You're going to be a speedster on these. All right, so we're going to divide by -5 here. So we're going to have 1, 0, 1, 3, 0, 1, -1, -1, 0, 0. When I divide by -5, I'm going to get 1, and this will still be 0. Think about what that equation is. Isn't that equation just -5z equals 0? So you see how z is equal to 0? That's all we're saying. Oops. Oh, man, I was too speedy. All right, 0, 0, -5, and 0. All right. Oh, 1. Yeah. Forgot what I was doing. All right, so our next step, what do you guys think? These two. Get them to be 0s, right? So we're going to get those to be 0s. So we do that by using row 3. So we're multiplying row 3 by something and adding it to row 1 to get the new row 1. Okay, so we're going to have, what do I need to multiply row 3 by?
0.
Nope, never 0. That makes it go away. You don't want row 3 to go away. -1, right? We want those 1s to cancel, so we need 1 to be positive, 1 to be negative. All right, I put that in the wrong spot. Hang on, it's up on the top. So I'm multiplying row 3 by -1, and I'm adding it to row 1 to give me the new row 1. All right, so my bottom row is still the same. That's the one that we're using. And I'm changing the 2 rows above it. All right, so what do we get? 1, 0, 0. What about the next one? Yeah, 3. -1 times row 3 is 0 added to 3. All right, and the next one is going to be, if I want to do the same thing, well, this is just adding row 3 to row 2, right? Do you see how they're going to cancel each other out anyway? You're going to get the 0. So when we add those 2 rows together, we get 0, 1, 0, -1. Okay, and this is where we're done because now we can tell what x, y, and z are. What are these equations? If you wrote them all out, the top equation would be 1x plus 0y plus 0z equals 3. In other words, exactly. What about this next one? Y equals -1. And the last one? Z equals 0. So we've now solved it. Okay. So yes, I know that was incredibly time consuming. I was showing every single step, okay? It will be much faster because we're not writing x, y, and z each time. It will end up being faster than if you did it with the x, y's, and z's. Okay, and it's just a nice method because it's like, if you just know the method, you can always do it, you know? All right, so do you guys want to try this one first, or do you want me to try it? Do you guys want to try it on your own, or do you just want me to do it?
Could you maybe start it?
Yeah. All right, so let's start it. So write what your first, like what your starting matrix will be.
You don't have 1 in the first column.
You can divide by something to get it to be a 1. Or you could, you know, if it was a 2 or a 3, you can work with it being a 2 or a 3. It's just kind of messy because then a lot of times you'll have like, you know, row 1 times something plus row 2 times something and then add them together. It's going to be kind of messy. So if you can get it to be a 1, it's the best. And I'm pretty easy on you guys. Like on the test, I usually give you 1 where there's a x equals, like the x coefficient is 1.
Thank you, Miss.
I know, I'm so nice. All right, so did you get that for your starting matrix? All right, so we have a 1 in that first spot, which is what we wanted. Now, if it had been one of the other equations that had 1x, you would just move that to the top spot, right? That's fine, you can move equations around. So our goal is to get both of these to be 0. So in order to do that, we're going to use row 1. And we're going to say, okay, I'm going to take row 1 and I'm going to multiply it by -4 and add it to row 2. So I get 1, 1, 1, 3 still on the top. And this is where you kind of do a lot of mental math, but like I said, you can write things down if you need to. So even if you just want to write the numbers off to the side, you have 1 times -4 gives you -4. Added to 4 gives you 0, right? You have 1 times -4 gives you -4. Added to 3 gives you -1. Right? You have 1 times -4 is -4. Added to 4 gives you 0. That was lucky. We like that. All right, and then -4 times 3 gives you -12. Added to 8. So -4. Did you guys see how we did that? All right, same thing on the next row. So the next row, I want to get rid of that 9. So what do I multiply row 1 by? -9, right? So -9 row 1 plus row 3. Okay, so again, if you need to write these numbers off to the side, that's fine. Some of you guys have trouble with your positives and negatives sometimes. That's fine. Okay, so we're going to do -9 times 1, and I get -9. I add it to row 3 as 9, so I get a 0. I do -9 times 1 is -9. I added it to row 3, which is 3, and I get -6. -9 times 1 is -9. I added to row 3, which was a 4. Right? You guys see where these numbers are coming from, the 4. So when I do that, I get -5. And then -9 times 3 is, oh, lovely, -27. Added to 7, -20. Do you guys see those? All right, what is our next step? We're trying to get it to be the identity, which has 1s down the diagonal, 0s everywhere else. What is it? Did you say? Huh? You could get the -6. I'm going to do this one. What do I need to do to change that to what I need it to be?
0.
It can't be 0. It's going to be a 1, right? We want it to be a 1. So what do I multiply by? Yep, multiply by -1. So your new matrix is going to be the 1, 1, 1, 3, 0, 1, 0, 4. And then if you don't like the negative ones, or the negatives down here too, like see how it's 0, -6, -5, -20. If you don't like dealing with negatives, you could also multiply that by -1. It doesn't matter. I mean, if it just bothers you that you have negatives, go for it. So we're here. Okay. Next step, 0 and 0, right? Can you get those to be 0 and 0? You want to try it? You're using row 2 somehow. So you're going to do something times row 2 plus row 1. So you have to figure out what you're multiplying by row 2. Okay, so go ahead and try that.